Up to now, I finished the first part of my lecture, and I'm ready for any question. It looks lengthy. It looks lengthy, but actually it is tasty. It is actually very, very tasty. For me, I love doing work with plates or something like that. About 70% of my work in plates, because it is tasty. You have a lot of taste actually in doing that. But if you do potential, something like that, you don't have indices, you don't have things to work with it. This part, when you test it, I remember there was a guy called Pen Lu. I don't know whether you know it or not. This guy, he turned out to be a pure mathematician at the end of the day. He did something in shells. He has 2 papers in the International Journal of Solids and Structures, and he did this, and I met him in England one time. I remember I was talking to him. I didn't know that this guy is Pen Lu. He wrote these 2 papers only. He asked me, what are you doing in your work? I told him I'm doing something in plates, in bending, and the plates on elastic foundation and something like that. He said, it's very strange. I have never met a guy is doing this. I have published 2 papers. Then I recognized it. Oh my God, you are Pen Lu? He said, yes, I am Pen Lu. And he told me, one day you will find yourself as pure mathematician at the end of the day. So every time you will increase the level of mathematics, increase the level of mathematics until you will not satisfy anymore from this engineering application and that things. So I'm asking you, try to work with some indices, microborer elasticity, plates and bending, fluid mechanics. Now I'm very interested in fluid mechanics actually. It is amazing actually. We have a lot of work in this area. So if we have any question, I'm ready actually.
Any question? Yes, there's this student.
We have yes.
Of course, yeah, nothing, but please explain.
Hohai, Lij
Page
is not equal
5.
to Lgi because of the minus sign. This is the triple L, right? Yes, because it is this minus sign. We have this minus sign. Where it is? Yes, it is. Yes, yeah. This minus sign. I wrote it in red. Let us do it here. This minus sign. So when you take the transpose of it, you get this minus sign is here. In this term. So this is the idea. Why? From where it comes? Why? I will tell you. I understand what you mean. Remember, when we write this integral identity, or as Professor Fu, he liked to say, we always have the differential operator. We always have the differential operator applied on our function times u asterisk, and we integrate over the domain equal to 0. And we use integration by part to pass this derivative to this one. Okay, so when we use integration by part, every time we say integral of u dv, for example, equal uv times minus v du. So every time we apply integration by part, so change our integral to another integral and swap the derivative with minus sign. So if we swap this, if we applied the integration by part one time only, so we end up with minus sign. If we swapped it twice, so we'll end up with plus sign. Okay, so minus minus, so we'll get plus sign. So as far as we have 2 derivatives, so we'll end up to the same operator. So if we start with even degree of something like nabla square, nabla 4, something like that, so we'll end up to the same operator applied instead here on u, here would be applied on u asterisk after the integration by part. But if we have single derivative, something like that, applied on u, we'll end up to minus u d alpha applied on u asterisk. We'll end up with minus. So when we have even degree of derivative, we'll end up to the same operator applied on the fundamental solution. But if we have odd degree of derivative, we'll end up with minus sign. This is because of that when we have self-adjoint operator, we always end up to the same operator, but when we have not self-adjoint operator, we'll end up to with minus this operator. Life will be a bit worse when we have complex numbers, because we'll have the adjoint operator, the conjugate actually, after that in the adjoint operator at the end of the day. Okay, this is mainly comes from the integration by part. This will be explained in details when we talk about the derivation of fundamental solution and when we transfer domain integral to the boundary. Okay, maybe this is not clear now, but be sure after 3 lectures or something like that, it will be clear. We have a question. Very interesting. Thank you very much. Okay, any other talk? I'm repeating, we have extra week. During this week, just write down your question or send me voice message on WeChat and I will reply direct. Okay, I'm enjoying replying boundary elements. I hope one day we will have something like customer service for replying boundary elements question. I will be the first guy to apply for this job.
Okay. Okay, so if no question, yeah, let's have 10 minutes break.
Okay, we'll have 10 minutes from now.
Yeah, okay, so see you.
Okay, see you. Bye.